In the previous video, we created this network graph here that shows the characters of Game of Thrones who have the most conversations with other people, and we created this network graph. And if you're working along with us, you can find this information, got1.csv, and you can find that as well as the Python code, which you see here. You can get all of that at drstephpowers.github.io/BIA, and we're doing these graph or network models here. Okay. In this particular video, we want to look at the spread of information between these characters from Game of Thrones. And in fact, this code comes from Harsh Jobanputra. I'm sorry, I mispronounced the name, who has built in these functions for these cascade models. Cascade models are used for looking at spread of infections, and so that's why you see the code talks about infection times, because we would use these, for example, to look at how COVID spreads, how the measles spreads between individuals, and it's because they come in contact with each other. And so we represent this contact here with these edges. Those are the lines to indicate that they have interacted with one another, and then the nodes represent people. So the function itself, what it does is it looks at when we have an individual, and we'll specify in a moment that individuals, let's say Jon Snow has some kind of story, and then passes it to Eddard Stark and Robert Baratheon. So then we can look at how it spreads through the rest of the network. So to set this up, we have two parts to this. One is calculating this infection. And so it's looking at who gets infected next. And then the other part here is this lovely code from Harsh GitHub site is then color codes the network to show how it moves throughout. So if we're just looking at the function itself for the independent cascade, we have our G, which is going to be our network. That is going to be our edge list here. And then we're going to have T, that's going to be time, and then this infection times here. So when we call this particular command here for these infection times, we're going to specify who that's starting that process. And so here we have this time element. So Jon Snow is going to be the initial, and then Stark and Baratheon are next. Okay. So that's going to set our initial infection times, who started it, and then it's going to cycle through time. All right, so what we have here is that it looks at if the infection time is N for a list of infection times, then we have time T, and then we're identifying who is infected at that point. Okay. So it's going through the neighbors, those who it interacts with, who are closest to it, as it moves through, and is some random number generation to that, as well as it's using our weights for what's the likelihood of talking to one person versus another to add some random walk component to the spread. Okay. And here what we're looking at in terms of our graph is that it is looping through the nodes, and it is looking at if the node is in the current infection list, then it is going to make them one color. So the idea of this function that's created here is that we are going to color code those who have been in contact with someone who's infected, and then when they become infectious, they become another color. And so that allows us, we go iterate through and build multiple graphs to see how this information or infection spreads. Okay. So we can change the titles here and set the font size just like before. We're turning the axes off. We're using the current infections that came from our previous function here. And we are then going to do the graphing. So I'll show you what this turns into. So if we start with our infection starting with Jon Snow and going to Eddard Stark and Robert Baratheon, we can loop through 10 time periods here, 0 up to but not including 10. and it's going to create a subplot. It's going to then plot based on the positions we've specified previously. And we're going to have the infection times in that time t. And then we're going to call that independent cascade to make it change. So when you run through this, it won't run because I didn't run the previous one. Let's start at the beginning. So Jon Snow has the information, the story that he's infected. He provides the information or spreads the disease, whatever that is, to Robert Baratheon and Eddard Stark. And then what you can see is that they then are infected, and then they're passing it on. So when we're looking at this random number generation and the weight that's here, well, here, where is this here? What it's determining is that Robert Baratheon has lots of contacts. Which particular contact is the one that the information goes to? That's going to depend on the weight, who do they talk to more often, but also the random number generation. And so what we see is that Robert Baratheon talks to Peter Baelish, Eddard Stark talks to Jaime Lannister, and then those people then essentially become infected, have the information, they then will talk to somebody else. And then it continues to move through the system. And if they happen to go to a person who doesn't talk to a lot of other people, then the infection dies out or the rumor stops spreading. And so we can see the impact then of who they talk to, as well as there is that random walk for if they happen to end up at someone who isn't well connected, then it doesn't continue on. So if we rerun this and see if it spreads to more. We can also change this so there's more people who are initially get the information. You could add another person or reduce the number of persons to change the flow. But the idea here with this simulation, and again, this is not my code, so we're very generously borrowing some code from GitHub here to show how you can use the network graph to show the spread of information or infection. So how you would go about using these network models or graph models in application.